Hello friends. So after understanding the definition and the formula of inverse Laplace transform, we will start with the numerical in which I am going to use those standard results or the formula of inverse Laplace transform to get the answer. So let's see here how to get the value of the question by using the standard results. Now here we have to find out L inverse, that is inverse Laplace transform of 1 minus square root of s whole upon s square whole square. Now guys, whenever we find inverse Laplace transform, we find it for the function of s. So here I can say that this is my function of s. Now if I want to get the answer of this, the answer will be a function of t. Now to get the answer of this quantity, what we have to do is we have to convert it, or we have to simplify this given function in such a way that we can use some standard result or some formula of inverse Laplace transform over here. So guys, let's start with the simplification first. So I'll write down the question again. So therefore now guys, let's start with the simplification, because then only we'll be able to convert this given function in the function such that we can apply the formula of inverse Laplace transform. So how to expand this? So here in the numerator I can see two terms, a minus b kind of, and we have square, so I'll apply a formula a minus b the whole square. So this will become L inverse of 1 minus 2 square root of s. So we all know the formula, a square minus 2ab plus b square. So 1 minus 2 root s plus b square, that is square of root s, that is s, whole upon square of s square, that is s to the power 4. Now guys, what we'll do is numerator we have 3 term, denominator we have 1 term. We will divide each and every term of numerator separately with s raised to 4. So that will give us L inverse of 1 upon s to the power 4 minus 2 into root s. Now root s is nothing but s raised to half upon s to the power 4 plus s upon s raised to 4, that is 1 upon s cube. Now guys, here there are 3 functions separated by plus or minus sign. So it means now I can apply the linearity property. So by linearity property, we can get the inverse Laplace transform of each and every term separately. So let's do it. So what is the inverse Laplace transform of 1 upon s raised to 4? So guys, if you have seen my previous video, I told you that in formula number 8 and 9 that here we get some number. I'll show you that formula again for reference. So you can see here that here I told you that we get question like 1 upon s raised to some number, and guys you can see here that here I got 1 upon s raised to 4. So I can now say that the value of n is equal to 4. So here we will get t raised to 4 minus 1, that is 3. So t cube upon 3 factorial. So here by finding L inverse of first term, I'll separate the terms, that is L inverse of 1 upon s to the power 4 minus 2 outside L inverse of, now s raised to half will come in the denominator, here it will be subtracted, so 4 minus half, that is 7 upon 2. So 1 upon s raised to 7 by 2 plus L inverse of 1 upon s cube. Now guys, here we'll apply that formula. So that will become t cube upon 3 factorial minus 2. Now here we have 1 upon s raised to 7 by 2. Now guys, don't use this formula, that is formula number 8, because if you use this, the value of n is 7 upon 2 Here you will get 7 by 2 minus 1, that's fine, but here you will get 7 by 2 minus 1 and we can't find out the factorial of fractions. So again we have to convert that into a gamma function. So instead of using this formula, let's use the formula of gamma function. So I'll use the formula number 9. So now the value of n is 7 upon 2, that will become t raised to 7 upon 2 minus 1, which is 5 by 2. So I'll get t to the power 5 by 2 upon gamma of 7 upon 2 plus here s cube, that will become t square upon 2 factorial. So guys, if you want, you can simplify the terms, that is 3 factorial is 6, you can simplify this gamma 7 upon 2 and we can get the final answer. So here I'll write down, so this will become t cube upon 6 minus 2 t raised to 5 by 2. Now what is value of gamma 7 by 2? So here I'll show you the formula. Gamma of n is n minus 1 gamma n minus 1. Now guys, we have gamma 7 upon 2 with us. So it is 7 by 2 minus 1, that is 5 upon 2 into gamma 5 upon 2. So now first 5 upon 2 I will keep it as it is, and for this gamma 5 upon 2 I will use this same formula again. So now I'll treat this gamma 5 upon 2 as gamma n. So that will become n minus 1, that is 5 upon 2 minus 1, that is 3 upon 2 gamma 3 upon 2. Now let's keep these two terms as it is, that is 5 3s are 15 upon 4, and for this gamma 3 by 2 we will use same formula again. So now n is gamma 3 by 2, so 3 by 2 minus 1, that is 1 by 2 gamma 1 by 2. And guys, we all know that the value of gamma 1 by 2 is root pi. So that is 15 into 1, 15 upon 8 into square root of pi. So I will put this value in the denominator. So that will become 15 into root pi upon 8. Next, it is plus 2 factorial. Now 2 factorial is 2. So guys, that will become plus t square upon 2. Now let's take this 8 in the numerator, that will become 8 to the 16, and we will get t cube by 6 minus 16 upon 15 into root pi into t raised to 5 upon 2 plus t square by 2. And guys, this is nothing but the answer of this function. So here we got the inverse Laplace transform of the function of s, and you can observe that the final answer is a function of t. Thank you very much.